Okay. All right. So I just wanted to, I remember one question where there was a bit of a doubt last time, right? I want to just quickly do that and then get a consistent answer. Let me just share screen. Okay. So this was the, are you able to see my screen, right? Okay. So this was the question. We solved this question as it is, and we got 7 by 72. If you guys recall. Recording is on, right? Recording is on. Okay, good. Okay, so we got 7 by 72. And then if you remember, I gave an extension to this question. I gave an extension to this question to say, what is the probability that at least 2, right? So at least 2. So I changed this to at least 2. At least 2. And then I said the easiest way to do that was 1 minus probability that all 4 are different. Okay, so that was 1 minus probability that all 4 are different is how much? The first one can be any one of the 6. The bottom can be 6 power 4. First one can be any one of the 6, 5, 4, and 3. Correct? So this was 1 minus, how much is this? 5 into 4 into 3 by 6 into 6 into 6. So if you simplify this, 6 6 are 36, 4 3s are 12. So it goes 3 times. So it's 1 minus 5 by 18, which was 13 by 18. But you guys, actually, I think you or someone who suggested a different way. Obviously, that was longer, but you should get a consistent result. And when I was explaining in class, it was not matching, right? And then later I put a message on the group. Not sure if all of you read it, but anyway, I thought I'll recap it. Okay. So his method was, we anyway know the probability for at least 3. Okay. So if we add to this probability, if you add 7 by 72 to the probability of exactly 2. Exactly 2 show the same value. Okay. And in this, Rohan pointed out rightly that this could be of 2 varieties. This itself could be a variety like A, B, C. That's one variety. I mean, the ordering does not matter. I'm just saying 2 numbers matching, and then the other 2 numbers are different. So A and A are same. B is different. C is different. And then the other category is A, B, B. Right? And the ordering we have to take care of in both of them. Right? And hopefully when we add 7 by 72 to this probability and this probability, we should hopefully get 13 by 18. That's where we had left off. Okay, so let's recap again. The probability of finding A. All of you okay with me so far? Is anyone lagging behind, or all of you consistent so far? Okay, cool. All right, whoever didn't watch the recording, I cannot help it. Hopefully you should have. Okay, so A, B, C ke liye, what are we doing? Again, bottom is 6 power 4. That's very easy. Bottom is 6 power 4. Okay, so for determining the top, first we determine which is that special number that comes twice. So of the 6, you're choosing one which appears twice. Having chosen that, we'll have to get two more spots. Sorry, not 2 more spots. Having decided which is that number which is going to appear twice, let's say we decided that 3 has to appear twice, and then we'll have the number 2 and we'll have the number 6. Okay, something like this. These are our chosen numbers. So to choose 3, it could have been 4 or it could have been 5, so that's 6 ways. Having chosen 3, where should 3 sit among the 4 spots? Maybe it should sit here and here, right? That could be chosen in 4 choose 2 ways. There are 4 choose 2 ways to choose which 2 spots. So this is actually 6 choose 1. Just to be very clear, I'm choosing of the 6, which is the special one, which is A. Having chosen A, what are the 2 spots that A will take, which is 4 choose 2. Now the remaining 2 spots are there, right? So I can go from, so I have 2 and 6, right? Whatever I don't care which one. Just imagine, I just grab any one of them, okay? And I decide to either put it here or here, right? So it's 2 ways, right? So the remaining 2. So there are 2 ways. Okay, so that's this. Now, the other category with Everyone okay with this one? A, B, C wala? You all agree on this? Okay, all right. And the other one, which is AABB, so 6 power 4 again. So here, so what is this example? So this example is where we are choosing two sets of, so let's say we are just choosing 4 will appear twice and 1 will also appear twice. But only thing is how to put it, right? Where to allocate them, right? So first we'll have to choose which are the two numbers from the 6. So that's 6 choose 2. So that will give us whatever that number is. It's giving what A is and it's giving what B is. In our example, it's 4 and 1. And then having done that, just grab the first number, whatever comes among 1 and 4. Let's say I can go in ascending order, doesn't matter, right? Let's say 1. 1 gets priority because it's ascending order, right? Even here in the earlier thing, you could say the same thing. There are 2 numbers left. Choose the lower number and allocate that first. The 2 could have come in either here or here. So that gets to go first. The other one gets to the other one, right? So similarly here 1 and 4, one of them will be smaller. I'll choose 1. 1 gets priority. Which of the remaining 2 spots, right? So not remaining 2 spots. Which of the 2 spots that 1 has to take among the 4? So that's 4 choose 2. Automatically, there's nothing else for the other number to choose. The remaining 2 spots go there. It's 2 choose 2. Otherwise 1. Both are same, right? 2 choose 2, which is 1. All of you clear on this one? And let's see whether this adds up. Okay, so 6 choose 2. Let's go to the, so this is 6 into 2 by 6 power 4. And then this is 6 choose 2, 6 into 5 by 2, which is 15 into 6 by 6 power 4 again. Okay, so let's simplify this. How much is this? So this is 2 over 6 square. So it's 2 over 36. And this is 15 over 6 into 6 into 6, right? I can cancel 1 6. 6 goes 3 times. So 3 goes 2 times. 3 goes 5 times. So 5 over. So 2 over 36. Whatever it is, 5 over 72. I hope it adds up right now. I hope. Mistake?
Sir, this option is not there anywhere.
What option is not there?
9 over 72. That's 1 over. Sorry, yeah, that's 1 over 9. Sorry.
No. I'm doing a different problem where the options need not even be there, right? This problem is already done. So
yeah, that's what I was confused.
This problem is already done, and that's 7 by 72. On top of that, we are adding another problem. We expect the answer to be 13 by 18.
Okay.
And hope we'll get there, right? So 2 over 36. Can you help me, guys? So 72. How much is this?
9.
9 over 72. Okay. 9 over 72. Does it add up now, or does it still not add up? Am I doing some other mistake now? 6 into 6 by 36.
So did you account for 2 choose 2 in the second part?
2 choose 2 is just 1, right? 2 choose 2 is just 1.
Yeah.
Okay. I did verify the other day. It worked out. Why is it not working out right now? 7 by 72 plus 16 by 72, is it? How much is it coming? 16 by 72. It should come to 52 by 72, right? 52 by 72. So it's 25 by 72. Am I doing some other mistake, guys? Sorry. 6 choose 1. 2. Oh, yeah. So here, in here, I chose what A is. That's 6 choose 1. And then I chose the space for A, which is 4 choose 2. I have not selected B and C, right? That still remains, right? I'll have to choose among the 5 numbers that are left. I'll have to select the 2, right? So I'll have to select 2 more. So I've selected A, that's 6 choose 1. Among the remaining 5, I'll have to select 2, which is B and C. And then allocate them, which is 2, right? So I was missing 5 choose 2, which is 10, correct? Which is 10. So it's missing a 10 here. So hopefully this will add up now. So yeah, am I right?
2 at the end.
What happened?
Why do you multiply by 2 at the end?
That's which place to put B and which place to put C in.
Okay.
6
Yeah.
choose 1 to select A. 4 choose 2 to select which 2 spots A goes. 5 choose 2 to select B and C from the remaining 5 numbers. There are 1, 2, 3, 4, 5, 6 numbers, right? And then having selected those 2, where to put them in the remaining 2 spots. All of you with me? Okay, so this is 20 by 36, so it's multiplied by 5, right? So this is 20. So how much is this? 49 by 72, right? How much is 45 by 72? Yeah, 45 by 72. 45 by 72. I think now it should add up. 45 by 72. So 7 by 72 plus, so this we got as 45 by 72 now. So when I add this two, I get 52 by 72, which is 4 goes 13 times, 4 goes 18 times. Okay. Again, very error prone as in, obviously for this given problem, the easiest way should be doing 1 minus where all 4 are different. But whatever it is, long or short, the answer should match, else there's something happening wrong. Therefore, it's worthwhile to do this and just pursue where the mistake is. Okay, hope you guys understood. If not, just go through. And Avinash, since you missed last class and probably you didn't watch the recording, there was a bit of a gap. Go back later, please. Whoever else. Okay. So that was one question. And then, okay. All right. So we have to pick up from question 8. Yeah, I put my own name on this one. The original question was slightly different, but I modified it slightly to make it a little more easier. So 15 identical marbles into 5 distinct cans. If you want at least 6 marbles in one of the cans and at least 1 marble in each of them, how many different ways can you distribute? So I've given the bins, right? The bins or cans, A, B, C, D, E are the cans and the number of marbles here. Okay. Any answer? Who wants to start? Anyone? Navya? Any answer?
I got 5 raised to 6 ways.
Please repeat. I didn't hear that well.
5 raised to 6 ways.
5 raised to 6 ways. Okay.
Yeah, I got 620.
620. Okay. One immediate observation I'll have, Navya. Whenever you have a number like 5 power 6 or something power something, that's typically the case when the entities that are being distributed are different, right? So for example, 3 different chocolates, or rather, let's say 5 different chocolates, and 3 kids, right? And how many ways can you distribute? Anyone can get anything. Some kid can go empty-handed, that's fine. So you take, sorry?
But aren't there distinct cans now?
The cans are distinct. The cans are distinct. The cans are like the kids. The chocolates are, if the chocolates were different, then each chocolate, the first chocolate can go to any one of the 3 kids. Second chocolate can go to any one of them. So it'll be 3 power 5, right? However, if the 5 chocolates are same, then you won't have the power wala thing. Does it make sense? Okay, so here the marbles are the chocolates, but it's identical marbles. It's 5 identical chocolates, in which case you won't have the power, right? So by some coincidence, it can still be 5 power 6. I'm not saying, but offhand, off the cuff, I would say it's wrong. But let's see. Okay, anyone else? 620. Okay, anyone else? Veer, what about you?
I had exams last time. I had exams
Okay.
like
Yeah,
this week
I know,
also, so I
yeah.
wasn't able to.
Yeah, I know many of you have exams. Okay, all right, let's discuss then straight away. Okay. Okay, so there are 2 cases, right? So I've given 2 examples, right? So if 2 cans take 6 each, then automatically there is just bare minimum left for the other 3, right? Bare minimum, you need 1, 1, 1. Bare minimum, you need 1 for each can. And then if 2 of the cans occupy 6, then the distribution is only 6, 6, 1, 1, 1, right? Some permutation of this. Okay, let's do this case first. 6, 6, 1, 1, 1. So all we have to do here is, how do we do this? Okay, in fact, I'll ask, let's see, Rohan, for the 66111 case, how many ways can I distribute for the second case?
How many ways can you what?
How many ways can I distribute based on this example? Like an example like this, how many will there be?
I don't understand. Like, it hasn't already been distributed. Are you asking for the number of ways to permute it?
Yeah, so this is just an example distribution where 2 of the cans have 6 marbles
Yeah.
and the rest of the cans have 1, 1, 1 each.
Yeah.
Okay.
Yeah.
In how many ways can I have such a case? Where
So it's
two-
5 factorial by 2 factorial, 3 factorial.
yeah, essentially 5 choose 2, right? I just have
Yeah.
to, yeah, exactly. So I have to choose 2 special cans which get 6 marbles. The marbles are all identical, so I don't care which marble is put where. So I have to choose 2 special cans which will get 6 marbles. The others get 1 each. So it's 5 choose 2 ways, which is just 5 into 4 by 2, which is 10 ways. So that's easy. The other case, actually, I'm thinking maybe we can combine all of it in one. Okay, let's see. Okay, so the other case, okay, no, maybe not. Okay, so the other case is, sorry, just one second. I'm just thinking here. If I have one of them has to be more than 6. Okay. Okay, all right. So what is the constraint we have? Okay, A, B, C, D, E, right? So all of them have to be greater than or equal to 1, right? Greater than or equal to 1. B is greater than or equal to 1. C is greater than or equal to 1. D is greater than or equal to 1. D is greater than 1. Okay. So I'm picking the case where there is only one can which has six or more. One second, guys. One can which has 6 or more. What does it say? If he wants at least 6 marbles in one of them, or at least 1 marble in each can. Okay, all right. So one of the cases has 6, right? So let's say C gets more than 6. Okay, so we want a distribution of 5 numbers where this becomes a little tricky. I thought it was easy only. I mean, we can still do it. Okay, so suppose I specify, for example, suppose I specify which is the can which gets 6 or more. Okay, let's say I specify that C gets 6 or more. Then, so in this example, right, I can convert this to another problem where A minus 1, so A is greater than or equal to 1, right? So we want A plus B plus C plus D plus E to be equal to 15. Okay, now A is greater than or equal to 1. Okay, so which means A minus 1 is greater than or equal to 0. Okay, so I can say A minus 1 plus B minus 1 plus C is greater than or equal to 6. So C minus 6 plus D minus 1 plus E minus 1 is equal to 15, correct? Equal to 15, right? Now, we want each of these quantities equal to 15 minus, sorry, I have to subtract something, right? A minus 1 plus B minus 1, I'm just subtracting the same number. So 1, 1, 1, 1, and 6, which is 10, which is 5. Okay, so I can frame another problem where I'll call A minus 1 as another variable. So A minus 1 is another variable, I'll just call it small a. So small a is plus small b plus small c plus small d plus small e. This should add up to 5. And each of these quantities can be greater than or equal to 0. Right? Each of these quantities can be greater than or equal to 0. Right? So now this is a standard problem, right? Distributing 5 chocolates to 5 kids. You use the partition method, right? So you have 1, 2, 3, 4, 5 chocolates. That's the 5 marbles, whatever. And then there's 5 people. Therefore, you need 4 partitions, 1, 2, 3, 4. And then based on the partition, for example, an example case could be like this. Another partition goes here, the third partition goes here, the fourth partition goes here. That means A gets 0, A gets 1. This is 1 marble. B gets nothing. C gets 2, D gets 2, and then E gets 0.
And so
Okay.
you commute the bars, right? To find the number of
Correct.
rows.
Correct. So how do we do this? So essentially, it's laying out 5 zeros and are there 5 marbles and 4 partitions, right? So it's just 9 choose 4. Right? So 9 choose 4, whatever that is, 9 choose 4. The only our additional complication is, okay, so understood, right? So in this example, that means small c is 2, which means what? Actually, the can C got 8, 2 plus the 6, which is 8. Okay, so that is, so the marble, the can which has 6 can be one of the 6 ways. So it's 9 choose 4 into 6 added to this. So 9 choose 4 is so much? 9 into 8 into 7 into 6 by 24 times 6. So this will be 3. How much is this? Let's see whether it adds up to what she got. 36 times 21. 36 times 21 is how much? 756, right? 720, 756 plus the 10 in the previous step. Does it make sense?
So, will the answer differ if I just keep it to A plus B plus C plus D plus E is equal to 15, and then I commute 19 choose 4? Sorry, find the number of combinations for 19 choose 4.
Yeah, because there, how do you guarantee that A gets at least 1? How do you guarantee that B gets at least 1? So,
Oh yeah, yeah.
so that's the challenge, right? Which is why it's always good to normalize and get everything, every entity gets 0 or more. That way you don't have that headache.
Yeah. Okay.
So
Yeah.
why 9 choose 4?
Why 9 choose 4? This one?
Yeah.
Oh, this is, okay, all right. I'll just go to another page. So forget this problem. Let's take, there are 1, 2, 3, 4, 5, 6 chocolates, 6 chocolates. Okay. And then there are 4 kids to distribute it to, right? And anyone can get any number of 6 identical chocolates and 4 kids, right? Now, how do you distribute? So you essentially have to insert 3 partitions. So I can insert a first partition here, a second partition here, a third partition here. What does this mean? So in between, so the four kids are P, Q, R, and S, let's say. Okay. So P comes, anything to the left of the first partition is his. So he gets 1 chocolate. Anything between the 2 is Q's. Q gets 3. Anything here is R. R gets 0. And this guy gets 2. So this is how you're dividing up the chocolates. So what do you have to do essentially? You'll have to insert these 3 partitions. 3 partitions because there are 4 kids, right? So in other words, I have to form a 9-letter word with 6 circles and 3 lines, right? The circles, 6 A's and 3 B's, whatever you want to call it, right? So in other words, in the 9-letter word, I'll have to select the 3 spots where the partitions come. 9 choose 3, right? Similar logic there also. Make sense, Kunal?
So I still didn't get how you got 9.
For this example,
Yeah.
there are 6 chocolates, 1, 2, 3, 4, 5, 6. And then there are 3 partitions. Therefore, essentially a 9-letter word, 1, 2, 3, 4. I have a 9-letter word where I'll have to arrange few marbles like this and few partitions like this.
Got it.
Does it make sense? Yeah, Navya? You're okay, right? Okay, cool.
So, but the problem is that, like, in this, what if they insert all the three, like, what if we insert all the three partitions in between two marbles?
Yeah, you can do that also. So if
It'll be only two divisions.
no, it'll still be three divisions. So what you're saying is it'll still be, I mean, four different rooms, right? So it's just that one guy gets everything. So for example, okay, 1, 2, 3, 4, 5, 6. So in this example, suppose I insert all of these three partitions here, and here. So P knows to grab everything to the left of the first partition. P gets 3. Q
Okay.
gets here, which is 0, and R also gets 0.
Oh,
S gets these.
okay.
Or even the other extreme case, what if all the 4 partitions are here at the far end? That's also fine. So P gets all of them.
Hmm.
Q gets 0, R gets 0, S also gets 0.
Yeah. Yeah. Okay.
Makes sense? Okay. Question 9. Question 9 should have been a fairly easy one, right? Kunal, did you do this or do you have exams?
So I didn't do this one.
Okay. Anyone? Ananya, what about you?
So I couldn't do this one.
Okay. Sharma, what about you?
I got 23.
23. Okay. Anyone else? Arya?
I also got 23.
Okay, 23 as well. Okay. Avinash and Shivank, I don't see you. And Vihan also has conveniently switched off the video. Guys, please don't make me ask, please. All right. Leave the, I keep saying video, I mean camera. Keep the camera on. Okay, 23. Okay, yeah. So let's see. Every school sent a team of 3 students. So which means the total number of students should have been, how many schools are there in the city, right? So total number of students who came should be a multiple of 3. Okay. Each participant in the contest received a different score. Andrea was the median. Hers was the highest score in the team. So A ranking was better than Beth and Carla. So B is at 37 and C is at 64, right? So if A is at 36, right? If A is at 36 and she's the median, remember, which means there are 35 ahead of her and there are 35 below her, right? So if A is at 36, then the total number of students would be 35, which is, this is A, plus 35 plus 1, which is 71, which is not even a multiple of 3. So that's not possible. So what if A is at the 35th position? If A is at the 35th position, then there'll be 34 here, 34 here. So, and there'll be 69 here. Okay. I'll just put A somewhere here. A is ahead of 37, that much I know. Okay. So there'll be 69, which is a multiple of 3. So, and does that change anything or something? So let's say this is the 34th position. So there are 33 numbers from ahead of her, 1, 2, 3, so on till 33. And then there are 33 numbers after this, ending in 69, 35, 36, all the way till 69 or how much? 67, is it? 67, right? 60. 34 ahead of her, 34 after her. So she's the 35th position, right? She's the 35th position. Sorry, I wrote it wrong. So she's at the 35th position. So she's at the 35th position, and therefore there are 69. So that's possible. So that's not violating anything. Similarly, if she is at the 34th position, then you'll get a non-multiple of 3. You'll get 33 plus 1, which is not a multiple of 3. If she is at the 33rd position, then what do we get? We get 32 plus 1, which again will not be a multiple of 3. So the next possibility is she can be 32nd position. If she is 32nd position, then there could be 31 ahead of her and then 31 behind her, which is 63. But 63 should be the last person, right? There's no one below 63. That's the last. But here we have a contention, right? 64 is already one person in her team. Carla is getting the 64th position. So it cannot be 63 or any other number below this. By this pattern, the next one would be whatever, 6 less, right? 57. That also not work. So nothing above this will work. Nothing below this will also work. Therefore, it's only 69 should be the correct number of students. And he's asking how many number of schools. Therefore, 69 divided by 3 indeed. So 23. Yeah. Arav, you did the same thing? Or was it Arya or Arav? You got the same answer?
It
Same
was me.
method?
I did a different
Okay.
method.
Go ahead, please.
I
What did you do?
so I used process of elimination. So I removed 22, 24, and 26 because when you multiply by 3, to find the median, you have to get 2 of the students and divide that by 2. But
Very good.
Andrea is the only one who got the median. So, and then I tested out 23 and 25, and then I did what you did, and I have 33.
Wonderful. Yeah, I really like that. So he eliminated all the even numbers because if you multiply any of the even numbers by 3, you get an even number, and the median will be, there'll be 2 medians, right? And you have to take the average. So clearly, none of the even numbers are possible, right? That's wonderful thought. Okay, and then between these two, we narrowed down quickly. Nice. Okay, that was question 9. Question 10. Arav, were you able to do question 10?
So no, I used the tree diagram, but I was getting the wrong answer. I think it's incorrect.
Okay. Anyone? Yeah, Arya, what did you get?
I got C, 1/11.
Okay, Navya, what about you?
Yeah, even I got C.
Okay, any other answers? Sanvi? Sanvi, I cannot see you. Same thing. Your head is at the bottom of the screen. Can you adjust the camera so that I can see you? Same with Veer as well.
Sir, I got 1/11 also.
You also got 1/11. Okay, Kunal. Okay. Sanvi, were you able to get an answer on this one?
No, sir, I think I got something wrong. I'm not sure where. I tried solving the question.
Okay. All right. So, so what are we doing here? 1 in 500 has a particular disease. So this is disease, and then this is does not have the disease. Let's say healthy or something, right? So this is 1 out of 500 probability, and then this is 499 on 500. And then for a person who has the disease, the test is always positive. So the test is positive or negative, and the test is positive or negative. So in this case, with 1 probability, the test will be positive. With 0 probability, test will be negative. And for a person who does not have the disease, there's a 2% false positive. So it's 2 out of 100 chance that it will give positive, which is wrong result. So this is the correct result. This is the wrong result. This is the wrong result. This is the correct result, right? So you'll get a wrong result with 2%, and you'll get a correct result in 98%. Okay. So now what is he asking? Let P be the probability that the person who's chosen at random from this population gets a positive test, right? So which means we are operating in either this branch, okay, or this branch, right? Positive result. Okay. And then which of the gets a positive result actually has a disease, right? So we want to select what fraction is the top branch of the total. So the top branch is 1 by 500 into 1. What fraction is that of the top branch plus the bottom branch? Bottom branch is 499 by 500 into 2 by 100. Okay, so the 500 can get cancelled everywhere. So effectively, it's 1 upon 1 plus 990. And how much is 998 by 100? Right. So which is 100 upon approximately 1100, right? Which is why approximately is 1/11. Okay, no other answers are even close. So we can safely mark 1/11. So fairly simple direct application of Bayes' theorem. Ananya, more or less similar proportion you did?
Yeah, I didn't do this one.
Okay. Okay, how about, sorry, Navya, did you do the same thing?
Yeah, sir.
Proportion. Okay. Whoever else got the correct answer, I'm assuming it's the same way, right? Does this make sense,
I
guys?
didn't do it this exact way.
Okay, what
I
did you
just
do?
said that like for the there are 500 people, right? So I mean, okay, that doesn't matter how many people are there, but 2% of the time will like be 2% out of 500, and only 1 out of 500 people has actually has the disease. So 2% of 500 is
2% of 500 kahan?
see, let's say there's only one person like who has the disease, right?
Correct.
So
1 out of 500 has the disease.
400,
Correct.
499 do not have the disease.
Correct.
And
Correct.
that's like, since it's asking for a closest to P, you can just approximate that 499 to 500. That's what I did. So now, out of that 500, 2% of the time, there is like there'll be a positive, a false positive test. So in total, out of the, suppose you take 500 tests, 2% of the time means 10 tests will come positive. But there's actually only one positive. So 10 tests of the false positive and one of the actual positive. So 10 plus like total 11 tests, and out of that only one.
Yeah. In other words, in the denominator, basically what you have done is this fraction, you have kept it as just 1. So this one, you kept it as just 1. So you just kept it as 1 upon 1 plus 2 by 100. Is that what you mean?
Yeah,
That
yeah,
would-
actually, yeah, that's kind of, yeah, that's what I did.
Yeah?
Yeah.
Okay. Yeah, you should get the same answer either way. Cool. That was question 10. Okay, let's go to there was the last question, or there's actually one more. Number of bad arrangements. Yeah, this is a good question. Rohan, were you able to get this one?
So I didn't attempt the homework. I only did 1 or 2 questions just now.
Okay, all right. Who else? Shivank, what about you?
I didn't get this one.
Okay, anyone got this one?
I sort of attempted it. I got 3.
3.
But I
Okay.
used like a lot of casework to do it, so I don't think it's right.
Okay, all right. At least you tried. That's good enough. That's good. Not good enough. Good. Bihan, what about you?
So I got 2.
2. Okay.
Yeah.
All right. So let's discuss. So let's understand the question clearly, guys. So what does this say? 1, 2, 3, 4, 5 are arranged in a circle. So I'll just give an example arrangement. Let's say 1, 3, 2, 5, and 4, something like this. Okay. Now arrangement is bad if it's not true that for every n from 1 to 15, you can find a subset of the numbers that appear consecutively on the circle that sum to n. So it's a very loaded statement. Okay, so let's break it down step by step. It's not true that for every n from 1 to 15, one can generate a subset of numbers. So can I generate a subset of numbers that adds up to, okay, adds up to, okay, adds up to 1? Yes, we can. I can just choose the number 1. Can I choose a number which, subset of numbers which adds up to 2? Yes, I can just choose the number 2. So by that same logic, 1, 2, 3, 4, 5 are safe because the subset can just be that number alone, and then it adds up to that number. So that's easy. Now the other extreme is also easy. The big numbers, can I get the number 15? If I add all of them, I get 15. Can I get 14? I can leave out 1 and add the rest, right? So 14 is also assured. Can I get 13? Same thing. I can leave out 2. Wherever 2 comes, I leave that out. And then I add all the others, right? So that's a collection which are adding up to 13. So similarly, that same logic, I can go all the way till 10. So 5 and below are safe. 10 and above are also safe. No matter what happens, we'll always be able to generate. So what's left is just 6, 7, 8, and 9. These are the only 4
Sorry,
numbers.
can you repeat what you said just now about the I was having some problem with my speaker.
Sure. So were you there till the part where 1, 2, 3, 4, 5 are safe?
I just heard that. I didn't understand why.
Okay. If I have to choose a subset of numbers that adds up to 3. So you understood the question, right, Rohan?
Yeah.
Okay. So from this collection, if I have to choose a subset of numbers that adds up to 3, can you do it?
Yeah.
How would you do it?
1 and 2.
But 1 and 2 are not consecutive here, right?
Oh, consecutively.
Yeah.
You can also
Only
just
three,
take
right?
right, obviously. So 1, 2, 3, 4, 5 are all safe. Yeah.
So sorry, Vihan, just 1 second. Rohan, what were you saying?
You can literally speaking take any number as a subset. So 1,
Exactly.
4, 5 are all.
Yeah. So I can select just 3 and say I can form 3 by the subset is just 3. Correct? Right. So that way I'm safe with 1, 2, 3, 4, 5 individually. I can take just that number and form that total. Okay. Ron, you're okay with me, right, so far? Likewise, the big numbers like 15 and below, 15 and a few below are also safe. I can form 15 by choosing all 5. I can form 14 by leaving just 1 alone and adding 2, 3, 4, 5. Right? So always there'll be, if I leave 1 alone, the other 4 will still be a collection, continuous collection, right? This collection will add up to 14. Yeah. And then if I leave out 3, for example, if I add all the others, right? If I leave out 3 and add 1, 4, 5, 2, I'll get 15 minus 3, which is 12. Right? So by leaving out any one of these individual numbers, I can leave out 1, I can leave out 2, I can leave out 3, I can leave out 4, I can leave out 5. Therefore, because these are all individual numbers, so therefore I can always generate totals which are 10 and above. That's where you interrupted me, Rohan. You're with me so far? Rohan?
Yes.
You're with me, right? Okay. So now that leaves us with just 6, 7, 8, and 9 to focus on. 6, 7, 8, and 9. But even here, if I'm able to form 6, then the rest of the numbers will add up to 9 anyway, right? Because the total numbers 1 plus 2 plus 3 plus 4 plus 5 is 15. If I'm able to add up to 6, then automatically I'm able to add up to 9 also, because the other set will add up to 9, right? For example, in this collection, 1 plus 3 plus 2 is 6. The other collection, which is 4 plus 5, is 9. So if I conquer 6, I've conquered 9 also. So I don't need to focus on 9. Similarly, if I conquer 7, I conquered 8 also. So bottom line, I only need to focus on just 2 numbers, 6 and 7, right? Because 6 implies 9, 7 implies 8. So if I focus on 6 and 7 alone, that's good enough. Now, I want a bad arrangement. Now, what is a bad arrangement that will prevent me from generating 6? So 6 can be a combination of 1, 2, and 3 collection together, or it can be a 1 and 5 collection together, or it can be a 2 and 4 collection together, right? So I must prevent this. So I want, let's say my goal is prevent 6 from happening. Okay. So I want to prevent 6. Okay. So I don't want 1, 2, and 3 to be a collection together. So I'll just say I put 1, 2, and 3 here. So obviously I want to insert something here, somewhere to block them appearing as 3 continuous numbers, right? In fact, I have to block in 2 places, right? Because even if I block here, they'll be here, right? So I need to block 2 of the 3 spots, right? I have to pick 2 of the, as long as I block them here, here, and here somewhere, they have only 2 more numbers left, namely 4 and 5. Okay. But 4 cannot be close to 2, right? Which means I obviously have to put 4 here only. And then 5 cannot be close to 1. Therefore, I obviously have to put 5 here only. So the only way I can block 6 is by an arrangement like this. 1, 4, 3, 5, 2. Counting. I don't want to draw a circle around this, right? I can arrange it neatly, but effectively it's 1, 4, 3, 5, 2 going clockwise. This way I have prevented 6. Is this clear, guys? Okay. All right. So next goal, let me prevent 7. There's no other way I can prevent 6, right? Prevent 7. So 7 ke liye, what are the groupings that I should be wary about? I can have 1 and 6. Oh no, there's no 6, right? So that I can have 2,
5, 2, 3, 4.
Yeah,
and
correct. 2, 5, 3, 4, and then 1, 2, 4
1
also,
to
right?
4.
1 to 4. Yeah, exactly. By the same logic, let me put 1 by the really exactly same thing, right? Only the number is different, but the concept is same. 1, 2, and 4, I'll put it like a tripod, right? Now I'll have to insert 3 and 5, but then 3 cannot be close to 4. So these are the 3 spots. 3 cannot be close to 4. I better put 3 here. And 5 cannot be close to 2. Therefore, I better put 5 here. And that's it, right? No other way I can do. Therefore, one way for 6, or rather to avoid 6. In fact, in this way, I cannot avoid 6. Oh, in this way, I cannot avoid 6. I only avoided 7. Likewise, in the other arrangement here, I could not avoid 7. So 7 was still possible, 4 plus 3. But I don't need to avoid both numbers at a time, right? As long as one number is avoided, it's good enough. So in this example, 6 is gone. In the other example, 7 is gone. That's enough to say that's a bad arrangement, right? And then he says all the arrangements which are a rotation or a reflection around this are considered the same, which means what? So I don't have to worry and count. For example, this 1 4, I can write this 1 4 3 like this, right? I can write this arrangement. If I write it like 1 4 3 5 2, it's exactly same thing, except that I'm going reverse way, right? Or I can put 5 at the top and start counting 5 3 4 1 2. It's just a rotation of what is already covered here. So all of these are all same family. I don't need to count all of them separately, right? So effectively only one independent way here and one independent way for avoiding 7. Therefore, yes, Vihan, 2 is the right answer. Very much same way you did, Mihan, or did you do something else?
Yes, I use the same method.
Okay, very well done. Okay, and Navya, makes sense? Or did you also get the same answer?
Yes, I understood.
Okay, were you able to do it as well, Navya?
No, so I got to the part where only 6, 7, 8, 9 was supposed to be added, but then I didn't know how to proceed.
Okay, that's fine. Okay, so that's good. 6, 7, 8, 9. Maybe you could have gone one more step ahead. 6 and 9 are effectively same. Okay, so if you reduced it to 6 and 7, that would have been good, but that's fine. Okay, no problem. So that was question 11. Was that the last question? Yeah, that was the last question in this paper, right? So let's go to the other test. Avinash, video off, camera off. Why do you guys do this, guys? Please.
Sorry, sir, I'd gone to the washroom. I forgot to switch it back on.
Okay, all right. Okay, so this paper, like I said in the announcement, more or less the difficulty level is neither too easy nor too difficult. From the 5 to 20 range of questions, the difficulty level I've picked. So I want to go quickly for the first few, right? The first one I don't even want to discuss. Fairly easy, 1.3.
Yes,
For whoever has done it. Whoever has not done it, then no problem. You can go back and do it. Question 2. Navya, what did you get on question 2? Actually, why am I just bothering Navya alone? Whoever else has had a chance to do? Yeah, Avinash, go ahead.
Yeah, I got E. Now I have to look for the question to see what.
I also got E.
Yeah, I also got E.
Okay.
So I got 39. I don't know.
39, which is E as well. Yeah, fairly simple question. So whoever has not done it, you can just add up all the angles at that point, at the junction, and then see what the remaining angle is. It's a fairly easy question. And typically the first few questions will be like this only. So I want to just mimic as much as possible as the real test. Question 3. What is the mean of P, Q, and R?
So I got 12A.
12.
I also got that.
12. Okay.
Yes.
Yeah, so just one small symmetry trick here. So, I mean, I'm sure you guys know this by now, but if not, so mean of P and Q is 13. So which means P plus Q is 26. Q plus R is 32. And R plus P is 14. Okay, I want mean of P plus Q plus R by 3. I want P plus Q plus R by 3. So you don't have to solve simultaneously or that. Just because of symmetry, add all of them together. So that gives 2 times P plus Q plus R. And then that will give you P plus Q plus R by 3. Right, so exploit symmetry. And it works in product also. For example, this is the, when you say mean, it's the arithmetic mean or the simple mean. If they say geometric mean is, so arithmetic mean is A plus B by 2. Geometric mean or GM is square root of AB. Okay, square root of AB. Okay, or more generally, it's A. If you have A plus B, n entities, A plus C plus B plus C by 2 by 4, and if there are 4 entries, it'll be A, B, C, D power 1/4. In other words, an arithmetic mean is something when you multiply by the total number of entities, it gives the sum. And the geometric mean is something which you raise it to the power, the number of entries, you get the same as the individual product, right? So if the geometric mean is G, that means G power 4 is my A, B, C, D. And if the arithmetic mean is, I don't want to use the word, okay? So AM, so 4 times AM is the sum is A plus B plus C plus D. Okay, so the reason I mentioned is you can use the symmetry type of thing for multiplication also. There can be another problem where they give PQ is so-and-so, QR is so-and-so, and RS is so-and-so, and then they want PQR or something, right? You can multiply all three together. That'll give you P square, Q square, R square. Okay, and then you can take the square root of that. So always apply symmetry. Okay, that was question 3. Question 4. What is the area? Avinash, question 4.
Question 4, I got C.
Yeah, I also got C.
I also got C.
Okay.
I got D.
D. Okay, let's discuss. I'm glad at least one of you got different, so it makes the discussion feasible. Okay, so octagon, right? So 135 degree approximately. Not 135 degrees accurate. I'm just want to draw something approximately 135 degree. So
it is 135.
Yeah, I know. I want to draw something that's approximately 135. That's where I meant approximately.
Also, I just realized I've written 4 only, but I wrote the option wrong.
Oh, okay, cool. Anyway, let's quickly discuss for those who might not have known. What's the total area of these 4 triangles, right? So this. So he connects this, and then this, and this. And then what is that area of the? Okay, so this is given to be 2, I think, right? So 2, 2, and then he wants the sum of these 4 areas. So each of these triangles is a 45, 45, 90. Therefore, by the 1:1 root 2 logic, this will be root 2, and 2. Therefore, area of each triangle is half into root 2 into root 2, and there are 4 of them. So it's indeed 4. Okay, good. That was question 4. Question 5. How many polygons? Navya, what did you get on this one?
I got E.
Yeah, I also got E.
So I also wrote E.
All right.
It's B, right?
Only you're saying B as in boy?
Yeah.
Only the quadrilateral. So if at all anything, it should be, see, the extremes, right? Why would it be only the quadrilateral but not the pentagon? If you go more, then you have more flexibility. Only pentagon at least is possible. But why would it be only quadrilateral but not pentagon? That doesn't make sense, right? Yeah, Avinash, are you with me logically?
Yes, sir.
Okay, but only the quadrilateral, Avinash, how is it possible? All 4 are the same length, but 4 different angles. 4 different interior angles. So which means all 4 are same, means it's like a rhombus, right? Not like a rhombus, it is a rhombus.
Yeah, yes, sir.
But then there'll be 2 pairs of equal angles, right? All the 4 angles will not be same.
Yes, sir. That's how I got the quadrilateral. I didn't know about pentagon or not.
No. And that my example, therefore I'm saying it cannot be the quadrilateral.
Oh, 4 different. Oh, okay.
Okay, 4
Yeah.
different, as in all 4 must be different. It's not like they can be like 3 of them can be same and 1 alone different. Even that is not allowed. They should be all 4 should be distinct.
Oh, okay, I read it wrong then.
Okay, a pentagon with 5 sides. Okay, how are you ruling out A? How are you ruling out only pentagon? Navya, I'm not saying you're right or wrong. I'm just asking you.
So because like if a pentagon will need to have a specific like sum of all of the sides, and if it has an equal number of sides, then if you divide it equally by 5, it should just give you the same interior angle length.
I didn't understand. You can always form a regular pentagon where all the sides are equal and all the angles are equal. Here the question is, can I have a pentagon where all the sides are equal, but the angles are different, right?
Yeah, but as soon as all sides are equal, it becomes a regular polygon which has the same interior angle measure.
As soon as all sides are equal, it does not become a regular polygon. In fact, even for a quadrilateral, we saw a rhombus is not a regular polygon. All the angles are not all angles are equal, right? So a rhombus is not a regular quadrilateral. Sides are equal, but the angles are not equal, right? So regular polygon wouldn't want all the sides to be equal and all the angles to be equal. A rhombus is a good enough example to show that sides can be equal, but the angles need not be equal, right? For a pentagon,
Sir, I wrote E because you could draw a house, like a house-shaped pentagon,
okay, if you draw a
but
house, then okay,
they would
then
be
these two angles are 90, right?
yeah, so it's automatically like at least two that are the same. So I assume that would
Okay,
for other
very
shapes.
good, very good start. All you had to do was tweak it a little bit. So okay, basically he's saying I can have a pentagon like this, right? So these three sides are equal, and I'll form an equilateral triangle at the top here. Okay, so this is so I have two angles which are 90. So this is 90. So this angle and this angle are same. Let's say this is, I should not use capital, right? I should use capital. So this is A and this is A. These two by symmetry are B and B. And this is 60 degree, which is the third one. Okay, so B and B are roughly how much? This is 90. All the five add up to how much? 540, right? So B, how much is this? 150, I guess, right? 90 plus. So B's are 150s, A's are 90s, and the top angle C is 60. Okay, but yes, as Rohan was saying, this does not prove anything because I have two 150s, I have two 90s. Now, all you have to do, Rohan, is tweak it slightly. Make this slightly come over this side. Okay, instead of 90, make it 91 or 92, doesn't matter. If it's possible to make it something like this, correct? If and similarly, keep this one as it is. Okay, so oops, sorry guys. Press something, mistake. Okay, so let this be P, Q, R, S, T, right? So T, I've moved it slightly to the left. So I've slightly moved it. R, I've kept it same. So that way I've made this 90 as 92 now. So 90 and 92 are different. Now with T and R, I can carve out equal some measurement, which will meet here and here, right? And that will disturb the balance. All I have to do is disturb the balance a little bit, right? So this will be slightly more than 150 or slightly less than 150. Accordingly, this will be something different. And this is anyway out of the league. It's anyways close to 60. So I can just disturb it slightly and still make it possible, right? Can you see it, Rohan? Everyone?
Yes, I had done it actually in the the last 5 questions I did in the last 3 minutes.
Sure. That's
I
fine.
had done it very good.
Okay, but does this make sense, guys? Everyone? Ananya, hurry with me. Okay. Sanvi, you're following along? Okay, good. I like Sanvi. Like all I get to see is her thumb. That's it. Nothing else. Space, no way. Okay. Kunal, you're okay, right? Okay. That was question 5. Question 6. Sum of 3 sides. Kunal, what did you get on this one?
Then I got
Yeah.
12.
12. Okay. Others?
So I got A.
So I got 8.
So I got 8.
I got 8 as
8. Yeah. Okay.
So
All
I
right.
got 8 as well.
Okay. Cool. Sum of the squares. The 3 sides is 98. Sum of 3 sides. Okay. So which A square plus B square equal to C square, and this has to be 49, right? Because A square plus B square plus C square is 98, and because it's right triangle, it has to be 49 each, which means one of the sides is 7, and the other 2 sides add up to 9, right? Because A plus B plus C is, so we have A plus B adds up to 9 and C is 7. Okay. And then we want, what do we want? We want the area, which is half AB, right? This is A, this is B, this is C, right? We want half AB. So we can just do A plus B whole square minus A square plus B square. right? So that's 81 minus 49, which is 32. So 32 is 2AB. We want half AB, therefore 1/4 of that, which is 8. Yeah, Avinash, pretty much same thing you did.
Kind of. I just did quite a bit more working.
Okay, but you understand the efficiency from
Yeah.
this?
Yes,
Right?
it didn't take much more time. It was just a lot more working.
Okay, all right. But time-wise, you were quick, right, on this?
Yeah, yes, sir. The first, I think, 10 questions were all very fast. After that, it started taking time.
Correct. Okay, so that was question 6. Question 7. Arya, what did you get on question 7?
I got 1-to-1 ratio. I think C.
Okay,
So I also got one.
Yes, sir. I got the same one.
Yes, yes.
right, same, right? So this is 1.5. This is 2. Therefore, this is 2.5 because 3:4:5 ratio, right? You can see the 3:4:5 ratio at work. Therefore, it is same 10 as the perimeter for both cases. Okay, that was question 7. Question 8. How many squares are exactly 4 greater than a prime?
So I got A.
A.
Sir, I got
Yeah, go ahead.
sir, I got
1.
You got 1. Okay. So
7, I got 1.
I got 1, sir.
Only 9.
only 9.
Yeah.
Whoever called out 0, Navya, was that you?
Yes.
9 is there, but how do you prove there's only 1, Avinash?
Yes, sir. So what I did is n square minus 4 is equal to a prime number.
Yeah.
So n plus 4, n minus 4, n plus 2, n minus 2 is equal to prime number.
Yeah.
And therefore n plus 2 should be 1 or n minus 2 should be 1.
The smaller one only can be 1, not the bigger one, right?
N
minus
n
2
plus
should
2
be
1, then it will be this thing. N is a negative number, so not possible. So therefore n minus 2 is 1, so n is 3.
Yeah, n is 3, right?
Same method.
Yeah, same method, right? So this becomes 1, this becomes 5. Therefore, 5 into 1 is P. Okay, there's no other possibility for n minus 2 and n plus 2 product to be prime. Yeah. Navya, realize your mistake.
Yes.
Question 9, area. Rohan, what did you get?
Sir, I got A.
A.
I also got A.
A. Fairly easy, right? Yeah, okay, good. So the two semicircles. Sorry?
It was not that easy, sir.
It was not
took
that
some-
easy. Okay, all right. Okay, so typically what I like to do in these area problems, if it does not strike you immediately, if it strikes you immediately, that's great. If not, don't worry too much. All I do is just mark each of these. This is A, this is B, this is C, this is D, and this is E, let's say. Okay. Now, just write out what your goal is. Your goal is what? A plus B plus C. Okay. And then what all do we know? Write that also. So I know the area of the first semicircle, A plus D plus C. Okay. I know the area of the second semicircle, B plus C plus E. And then I know the area of the triangle. I know D plus C plus E. Okay. Now just glance through and see whether I can do some combination of these. I can form this, what my goal is. And I can clearly see that if I do 1 plus 2 minus 3, that gets it, right? Does it make sense, Rohan?
Yes, sir.
Okay,
Yeah.
that helps. Yeah,
Yeah,
but
that's what I
yes.
did at the end.
Okay, cool. So numericals, all of you, I guess, since all of you got consistent answer, it must be right. Fairly easy, right? I mean, reasonably okay.
Yes.
Okay. A good question for around 9th question. Okay. Question 10. Are we able to do this?
So sorry, I don't have solving of all the questions right now.
Sorry, I didn't understand. What do you mean? You don't have your workings with you?
Yes, I am
Okay.
just checking it. I just highlighted some of the questions on my computer itself.
Okay. All right. Sharma, how about you?
The 10th one, I think I got 5.
5.
Yes.
I also got 5.
Yes,
Okay.
sir.
All right. So hope you guys did it efficiently. So I can see the numbers are all very tempting to add to get 1000, right? So if I add this equation and this equation, I get 1000x plus 1000y equal to 5000, right? So x plus y is 5. Okay, and then we can
And then
all
you subtract it,
I
and
can
then
also
you can
subtract.
get x minus y is 1.
Exactly. If I subtract, I get x minus y equal to the same, the 944 or 954 on all the three numbers. X minus y is 1. And then we want x plus y times x minus y, which is just x square minus y square. Therefore, it's 5. Okay. That was question 10. Question 11. Yeah, Vihan, we're able to do question 11.
So, yeah, I got 84, but I think I made a mistake because I wasn't fully confident with my answer.
Okay.
So I got 108. It was slightly
108.
I got 108.
Okay. Navya, what did you get?
Got 108.
108 as well. Okay. All right. I hear multiple answers 108. So very likely that's right. So let's see. 2 squares are p square. Okay. So what are the numbers? 1, 2, 3, 4, 5, 6, 7, 8, and 9. Right? And then it's possible to choose 2 different numbers. In 2 different ways, 6 numbers, which is the product is a perfect square. So clearly I cannot choose 5. I cannot choose 7 because they don't have Jodi at all. Yeah. So that eliminates two numbers. I'll have to only select the remaining may. In other words, I have to leave 1 number from the remaining, right? So obviously I don't want to leave which are perfect squares. So these will be candidates that I'll definitely want. So and this is also 1 is also a perfect square, right? So it just comes between 2, 3, 2 into 3, and 2 cubed. Among these, I'll have to leave out 1 because these are definitely in, right? And then I need 3 more, which means among these, I'll have to leave out 1. So I can just go 1 by 1 and see if I leave 2, then am I fine? Yeah, I'm fine because this will be perfect pair, right? I have 2 3s and I have 4 2s. So I'm okay with leaving 2. Okay. So I can leave. And then similarly, can I leave 3? No, I cannot because the 3 here and 3 here. So I cannot leave 3.
So you can, I think, leave 2 cubed then, right?
Yeah, I can leave 2 cubed. So the only possibilities are leaving 2 cubed or leaving 2, right? And then once you figure out, the rest comes out, right? So you can find the product of the others.
72.
Okay. And since many of you got the same answer, 108, should be fine, right? I don't remember offhand, but this is how you would work out. Okay. Hope all of you did very similar, right? Or was it a little longer? Anyone? Okay. Kunal, camera on. Every now and then I have to tell someone's camera is off. Okay. Question 12. Yeah, Navya, what did you get on question 12?
So I don't think I got question 12.
Okay, it was not that difficult. Arya?
I got my answer is C.
C. Okay.
So when I got C, but I'm not sure.
Okay. Anyone else? Any other answer? Rohan?
Sir, I did not end up attending. I didn't have time for this question. But I had put A as the option anyway, just to guess, because I didn't have time.
Okay. All right. Okay, let's see. So yeah, the question looks daunting, but the diagram has it all, right? So the only thing is Q, X, and V should be on a straight line. So the slope from Q to X and the from Q to V must match, right? So QV, that slope doesn't matter. Rise over run, whether it's negative or positive doesn't matter. Let's take from V to Q, you're going down by D and then going horizontally by B. So that's the slope from Q to V. So V to Q, whatever. Suppose you have to go from Q to X or X to Q, then you have to go down by A, and then you have to go horizontally by B minus C. Okay, so this must match A upon B minus C. Right, A upon B minus C. And now if you just cross multiply, you should be able to get, so DB minus DC equal to AB. Okay, and all of these answers are plus, plus, plus. So I'll move the DC to this side. So I'll say AB plus CD equal to BD. Okay, and then I'll divide. Since all the answers to the right are 1, the easiest way is divide throughout by BD, so that one of the sides becomes just 1, and then the right hand side now in this case becomes. Am I doing some mistake, guys, or I'm fine? A by D
Correct.
plus
You're correct.
C by B. Yeah.
So can you repeat?
So I didn't use this method. I used some ratios to find it out.
Yeah, multiple ways. All of them are very similar. Yeah, I'll repeat it, Rohan. Just 1 second. Avinash, what did you do?
I
You said
just
ratio.
used some ratios. I don't have my working for this question. I just
That's fine.
remembered I
But
used,
eventually, all of these ratios
some
are going to add up.
ratios to
Are
get
going
there.
to culminate in the same slope equivalent. Okay, so Rohan, which part did you want me to repeat? The first one, is it? How do I come up with this equation?
Yeah, that's all. Because otherwise, after that, I just rearrange.
So if QX and V are in a straight line, that means the slope of QX should match my slope of my QV. Or
Yes.
whatever, Vx, or you can choose anything. We can choose Vx, you can choose Vq, you can choose XQ. There are 3 lines, essentially 3 points, right? You can choose any 2 different pairs and then set the slopes to be same. That's it. Okay. Yeah, it looks like a daunting question, but sometimes daunting questions are the easiest ones, right? Okay, so that's question 12. Question 13. Ananya, did you get question 13?
No, so I couldn't do this.
Okay, anyone?
So I got D.
D, okay, 9 pi by 2. Okay, Arya?
I also got D.
9 pi by 2. Okay, anyone else? No one? No other answers? Okay, all right. So I'll just use the same diagram. So let's say this is, Navya, what did you get?
I also got D. I was not
Also
able to.
got D. You were not able to what? Sorry?
Unmute, sir. I also got
Oh, okay, okay. Navya, did you say something?
No, sir.
Okay. Were you able to get this, Navya?
No, I tried and I got into a loop, so then I ended up with the original answer.
Oh, okay. All right. So let's say the bigger circle, or rather there are 3 circles, right? The bigger small circle has a radius of A, let's say. Okay, so this is, okay, so this is A. So counting from here, counting from the base, this height is A, let's say. This is A. That's the big white circle ka radius. And let's say the small white circle ka radius is B. Okay, so this is B, let's say this is B. Okay, so if you count the height from the base all the way till the top, so this will be, again, multiple ways to do it. I find it easy to just record everything clearly, right? So this is 2A plus 2B is the height of this, 2A plus 2B, right? 2A plus 2B. Now the center, therefore the radius of the big circle is A plus B. So the radius of the big circle is somewhere here. The radius of the big circle, right? Let's say this is the radius, that's A plus B. So this height here in, right, this is A plus B. Okay, so the 3 radii are now A, B, and then A plus B. So A plus B being the biggest one, and then which is bigger than the white circle, which is A, and then the small circle, which is B. Okay, now somehow we have to get the chord in the picture here. So I can just draw, I can connect this. I can connect this from center to this, and then I can form a Pythagoras theorem here, right? Okay, so let's say this meeting point is whatever, I don't have to label. Okay, fine, T. Okay, so this gap is how much? So this gap is
A.
No, B, because you're drawing from the other circle, no?
It's actually A minus B, right?
A minus, sorry, yeah.
Why is it A minus B? Essentially, it's nothing but it's the diameter of the, it's the diameter of the white circle, right? The big white circle minus the radius of the the big circle, which is A plus B. I'll repeat it once more again. I didn't say that clearly. So the height that I'm seeking here, which is this height, is nothing but this height, right? Minus this height. Okay. So this total height is 2A. And this height is A plus B. If I subtract both, this height becomes A minus B. All of you with me? Navya, are you with me? Okay. And now therefore, so TQ now therefore becomes A plus B square. So this is A plus B, and this is A minus B. We have plotted. So A plus B whole square minus A minus B whole square is your TQ square. So TQ becomes whatever 4AB square root. Okay, sorry, 4AB, right? 4AB square root. And what does he want? I forgot what he wants now. What is the area of the shaded region? Area of the shaded region is the big circle. Okay, what is the goal? It's always important to write what the goal is. So goal is the big circle, which is pi times A plus B whole square, minus the two circles, which is A square and other one is B square. So it's pi times A square, B square will get cancelled. So 2AB. So we want pi times 2AB. So we know that, in fact, I'll just keep y even just keep TQ square. TQ square is 4AB and TQ is about half of 6, right? Which is 3. So TQ is 3. Therefore, TQ square is 9. So 9 is 4AB. So 9 is 4AB. Therefore, AB is 9 by 4. I can substitute that here. So pi into 2 into 9 by 4, which is 9 pi by 2. Yeah. Whoever didn't do it, hope this was clear now. Okay. Kunal. Okay, you got it. Okay, cool. Next one. Perimeter rectangle is divided into 4 parts. Avinash, yeah.
I got D.
96. Okay. Any other answers? Navya?
Yes, I got D.
Ananya, all of you got 9. Okay. So fairly easy, right? So this is A. Let's say this is B, C, and D. Then he has given the perimeters of 2 of them, right? So A plus C is given to be 14, right? Because 2A plus 2C is 28. And then B plus D is given to be 6, right? 12 by 2. And then he wants area of the whole rectangle. For the whole rectangle, we know the perimeter is A plus B plus C plus D, right? A plus B is one side, C plus D is the other side, which is 20. So we need 2 numbers that add up to 20. And what can the product be? We can just eye glance through this, right? You can see that none of these products is happening. This is happening. 12 times 8 is 96. Okay. So
Sir?
suppose, yeah, go ahead.
Sir, if A plus, so I made this mistake. I don't know why it's wrong. If you
Yeah.
know the value of A plus B plus C plus D,
Yeah.
why can't you just multiply it by 2? And that's why I kept getting 40 as my answer. And then
But
I
he
didn't know.
doesn't. But he doesn't want the perimeter. He wants the area of the original.
Oh my God. Oh, okay. Okay. Sorry. I misread the question.
Okay. All right. Oh, one other question. One second. All right. How many different areas are possible, guys? How many different? So 196 was one. How many different possibilities are there for the area?
10.
10. Okay. Anyone else?
So I'm not sure. I used some casework. I just tried trial and error for these.
No. For this problem, we are done.
Yeah.
I'm just asking another potential question, right?
Oh.
You can try it now. Yeah. How many possible areas are there? Could be another question. If it comes, then what will you answer? Anyone? Ananya?
Sir, I got 10.
Oh, you were the one who called 10? Okay. Someone, I thought it was Kunal who called out 10. Okay. Kunal, didn't you call out 10? Wait, Kunal even there? Okay. I don't know. I heard a boy's voice say 10. Okay. All right. Any other answer? Vihan? Shivank?
So I'm getting 5.
5. Okay. Arya, go ahead, please. Yeah.
Yeah, I also got 10.
10. Okay. Let's see. So A plus B is one side. So C plus D is another side. Okay. They have to add up to 20. So the bare minimum that A plus B can be is 2, right? Otherwise, there's no rectangles at all. Okay.
2 and 18.
2 and 18. And this can go all the way till 10 and 10. Right? So there are 9, no, not 10. From 2 to 10. Therefore, there's 9 possibilities, right? Right, Arya, do you agree or? What?
Yeah, I accidentally counted 1 and 19.
Okay. You started counting from A plus B equal to 1, is it? A plus B equal to 1 means one of them is 1 and the other one has to be 0, in which case there's no rectangle at all, right? Yeah, makes sense. Probably the people who called out 10 did the same mistake. 5 way off. I'm not sure beyond what you did to get 5. Okay, Navya, what about, you got 10, 9? Or
Yeah, I just did 10.
just as I was discussing, you got it. Okay, so fine, sounds good. Hexagon, Navya, what did you get? Question 15.
So I got a value that wasn't like in the question option.
Okay, all right.
So this one I got E.
8 minus 4 root 3.
So I also got E.
E. Okay, all right. The side is 2. This side is 2, right? Again, multiple ways to do this. So this is 2 and this is 2. And then I want to, what is the overlap area of the 2 squares? Okay, so what is the overlap area of the 2 squares? This rectangle, right? So it's nothing but the 2 squares minus the whole rectangle.
Yes, and I think the only option here that even worked would be 8 minus 4 root 3. I didn't even solve it further.
Okay, that's very intelligent because he's saying this one is 4 and this one is also 4.
8.
Yeah, and this one should have some 8 in it. So 8 minus something. Okay, that's very, very cheeky. That's good. From a test taking perspective, that's perfect. But actually to get it as 4 root 3, let's just complete it. So we know this is 2 and this is 2. And therefore, this is by the 30, 60, 90 rule, this is root 3, right? And therefore, this whole thing is 2 root 3. So this area of the rectangle becomes 2 times 2 root 3. So it's 8 minus 4 root 3. Make sense, Navya? Make sense? Who else did not get 8 minus 4 root 3? No, it's fine. What I meant is, did anyone else get any other answer which is in the choices? Okay, all right. Next one. Pi wala question. Arya, what did you get on the pi?
I wasn't able to do any more questions after 15. I didn't have any more time.
Oh, okay. I forgot to mention this. Even if you run out of the time, do complete the questions, at least for class discussion. Yeah. I meant to say that, but going forward, please do that, guys. Okay. Yeah, Navya, what did you get?
I got B for this.
B 18. Okay, Rohan?
So I also got B.
B, Ananya. Okay, cool.
Sir, I got E.
E. Okay. All right. So what does he say? Cherry pie cost same as?
Even I got B.
B. Okay. C is 2A, and then B is 2D, and then cherry pie and 2C plus 2D is same as A plus 2B. Okay. So let's convert everything in terms of the. Okay. Let's convert everything in terms of D and A. So D is just D. Okay. All right. So C is 2A plus 2D equals to A plus 4D. Okay, so which means 2D equals to A. So D is the smallest. We can write everything else in terms of D. So D is just D, A is 2D, and then B is also 2D, and C is given to be 2A, which is 4D. So you got everything in terms of D. Now he buys one of each, so we just have to see what the multiple is. 8, 9, so 9D, whichever is a multiple of 9, there's only one, which is this. Rohan, what is your mistake?
Sir, I had the same idea that it would be, but I got 12D somehow, and I got C is equal to 6D, and A is equal to 3D. So something I must have done.
Yeah, all right. Some silly mistake you can check.
Yeah.
Okay. Yeah, fairly easy question only.
Yeah, it was an easy question.
Yeah. 17. Sharma, did he do 17?
No, I didn't have enough time to finish the.
Okay, all right. And therefore, whatever was left, you guys didn't attempt. Avinash, what about 17?
So I didn't do 17. I'm
Okay,
not-
Shivank. Shivank, you had test, you said, right? Or you attempted this?
So can you repeat it?
Is 17, were you able to do this? 17?
So I
question?
didn't.
Okay. All right. Ananya, yeah.
So I got a B.
B. Okay, Rohan.
So I got C.
Okay, fine. That's good. Let's discuss. So, Navya, did you have anything on this?
So I also got C.
Also got C. Sorry, Navya, I couldn't hear you. What was that?
I didn't get any question after.
Okay. So, sorry. So what is this? This is a rectangle. My God. Okay, rectangle. And then you have some thing around it, right? Another rectangle here. So X stones by Y stones adds a border of 1. So this is X and this is Y. And all the borders are 1, 1. So the outer area is X plus 2 times Y plus 2. Okay. So, and then this border area should match the same area as the inner rectangle. So it just should be 2 times XY. Okay. So let's simplify this. So XY plus 2X plus 2Y equal to 2XY. Let's get everything to one side. So XY minus 2X minus
plus 4.
Plus 4. Yeah, plus 4. Thank you. Plus 4. Okay. So XY minus 2X minus 2Y equal to, let me leave the 4 on this side. Okay. So the standard trick in these cases is to factorize this. So I need a XY term. I'll put a X here. I'll put a Y here. I'll need a minus 2X. Therefore, I'll put a minus 2 here.
So if 4 goes on the other side, wouldn't it be minus 4?
No, I kept the 4 alone on this side. I kept the 4 alone on the left side.
Okay.
Okay, I kept the 4 alone on this side. Okay, I moved everything else. Okay, so XY, to force XY, I put X here, or I put Y here. To force a minus 2X, I put a minus 2 here. To force a minus 2Y, I put a minus 2 here. But then this introduces a plus 4, right? Therefore, I have to compensate by adding 4 on the left side. Now, it's just product of two numbers, X minus 2 times Y minus 2. Each of them has to be greater than 0, right? Because the inner rectangle has to be a proper rectangle. So how many ways can we get 8? Yeah, I don't think the 0 is a problem, but it's a 1-8 combination, 2-4 combination, 4-2 combination, and 8-1 combination. 8 is a small number, therefore I listed it out. Otherwise, you know how to list the number of factors. So therefore, there are 4 possibilities for X minus 2, and therefore 4 possibilities for X itself. I don't have to worry about the individual numbers. Maybe I can just use one to check, but otherwise I don't care. I only care about the count. Right? Does it make sense? So 4 ways. And this factorization technique is very important, right? So there can be another situation where I don't know, I'm just making up something, xy minus 3x plus 4y equal to 16 or something. Okay, I'll change the question later, but right. So the idea is same. I want to introduce x, I want to introduce a y here so that I have a xy. And then to have a minus 3x, I'll force that by putting minus 3 here. And to force a plus 4y, I'll put a 4 here. Okay, and I'll just change this question to be, now that I know, I'll just make this 108. Okay, now what have I introduced? I've introduced a minus 12 on the right hand side. Therefore, I have to compensate with the minus 12 on the left hand side as well. Therefore, the problem becomes how many products which will give 96, right? And that's an easy problem. The number of factors for 96. However, let's say the question is how many ordered pairs. Actually, can we do this? How many ordered pairs of integers x and y are belonging to integers? how many ordered pairs are there where this product will work out to 96? Can you guys all do it quickly?
So 2.
2.
No, sorry.
2 seems such a small number. No, 2 ka matlab kya tha? I don't know. What did you think, Ananya, when you said 2?
So I thought like x will have 2 values and y will have. So I thought that because there are 2 factors, like 2 brackets, like 2 sets of brackets, there will be 2.
Okay, but you agree there's a lot more than 2, right? Okay, karke batao. Okay, Navya, you have an yeah. You can call out your answer. Doesn't matter. Let people do it.
Maybe 24.
24. Okay, all right. We'll wait for other answers. Yeah, anyone else? Rohan?
Sir, I'm trying to do it mentally.
Okay, that's good. Come on, guys. Anyone else?
So I'm also getting 20.
Okay, explain your 24, Vihan. Vihan.
So 1 second. I'm just doing the work. 1 second.
So it will have to be less than 24.
Okay, less than 24. How many then?
So I don't know. So I'm just saying it'll have to be less than that, because if you get 24, I'm assuming you're counting the number of factors of 96 and multiplying by 2 to permute it. But
Yeah.
you have to take into account the fact that it's x plus 4 and y minus 3. So
Yeah, because 96 x cannot be 96 and y can't be 1. That won't work.
yeah.
Okay.
No, x4 is
X plus 4 is 96, y minus 3 is 1. Oh yeah.
Wait, but why does that?
Okay. Explain your answer, Navya. Yeah, Navya, explain your answer. So
yeah.
96 is how much? 2 power 5 times
Right.
3 power 1. Okay, go ahead.
62, which is 12.
Yeah.
And then it asks ordered pairs. So x comma y and y comma x will be different.
No, but it has 12 factors, right? So the 12 factors include 1, 2, 3, all the way till 96. So x plus 4 can be 12. X plus 4 can be 1, or x plus 4 can be 2.
Yeah.
X plus 4 can be 9. Therefore, there's only 12 different, no? Why multiply by 2?
Oh, yeah.
Do you agree? Okay. And Avinash, she will make it. You just care about x plus 4. Treat x plus 4 as z or a. Treat
Yes,
y minus.
I realized that.
Answer 3 will go away. 3 of the factors will go away just because x plus 4 the a has to be great. Like you can't have an x value that's negative, right? So all the factors where x plus 4 is
I was
1, 2,
just
and
going
3
to
are
come
all
to
right.
that. In fact, the 24 is the correct answer for the wrong reason. There's no need to multiply by 2 for the ordering, but the reason to multiply by 2 because for every one of them, I can put the negative pair also. So x plus 4 can be 2 and y minus 3 can be 48, or it could be minus 2 and minus 48. And therefore, you need 12 into 2. I just said they're integers. I didn't say they're negative integers. And therefore,
but you can't have negative integers.
I defined a problem where they're integers. I didn't say positive integers. I said z. I didn't say z plus.
So, but you said it's in
No,
the
but based on the
delta
question
problem.
that was
Yeah,
given
that's why.
earlier, you can't have negative people, no?
I didn't talk about the rectangle wala question at all. I said,
I said, sir, I thought you did.
That way, why will I get x plus 4, right? Y minus 3. I changed from the rectangle long ago. I just said, to solve these kind of problems, you will use these. Okay, sorry if that was a confusion. Yeah. So
Yes.
anyway, multiple levels. But yeah, be careful. Integers is what you care about in this problem. If it's positive integers, then you're right. Then you have to worry, is y minus 3 positive, right? Then you'll have to avoid y being 1. You have to avoid y being, no, even then y minus 3 should be fine, right? If y minus 3 itself is positive, then y will be positive. X plus 4, you have to worry. If x plus 4, that factor is 1, then x becomes negative. That worry is there, which is why I made the question easy by saying integers. I didn't say positive integers. If I say positive integers, in fact, it's slightly tricky. It won't be 12 in that case. It'll be fewer than 12
Yes,
because
that's
of
right.
these restrictions. Okay. All right. We are up on time. That's fine. Let's stop here, guys. Of course, the last few questions are the most important, but we'll discuss. So there'll be some extra classes. I know next week is Diwali week. We'll meet, but there'll be an additional class I'm planning to keep.
So is there class tomorrow or no?
Tomorrow there's no class.
Okay.
So I combined tomorrow's and today's to be today. The next class will be obviously what today's.
So, but isn't AMC on 8th?
Yeah, 8th and 14th. So the next class.
So next class is before after AMC, no?
Yeah, correct. Next class will be next Sunday. But I'm planning to keep one after that and before the 14th, right? So, right. Shoot. When is the exam? 8th and 14th, right? Yeah. So very likely, very likely the 13th, right? 13th has to be we have to have a class. Either I'll have a class on 13th or I'll have a class on 9th or 10th. Okay, I'll decide. Anyway, it's after 8th. And you have the regular class anyway. And then I'll have to have one more class at least. Okay, or I'll communicate on the group, guys. Okay, that's best. I don't want to plan anything offline here. Okay, chalo, bye. Hope it was useful. And the last few questions we'll discuss. Those are the more important ones. But please go through whoever hasn't done it.